Hello everyone, I'm Xavier Young. Let's talk about our homework 2 question 9. You can see it's from our textbooks in appendix C, actually C2 question. We will only do the question A, part A. So after reading the questions, um, there are two kind of branches. One is the conditional. The second one is the, I would say, unconditional. So unconditional here, actually just the jumps, right? And conditional will be just the conditional. And conditional can be like take or not taken. So, and from the question we know, for unconditional there are 1%, and for taken will be 15% of 60%, and not taken will be 15% of 40%. So that is 9% and that is 6%. So we got like how many branches will happen in our instruction streams. So let's go through the question. We can see here is a 4-stage. So 4-stage means the one instruction will take 4 cycles to be completely executed or finished, if ideally. And there are something we need to know is that the branch is resolved at the end of the second cycle for the unconditional branch. So for jumps, we need to wait until the second cycle to know the result. And for the conditional, we should wait until the third cycle, yeah, to know the result. So yes, I think that's the, oh, it said only the first pipe stage can always be completed independently. So we can see the IF instruction fetch can be always taken, or always take whatever you need to wait or not. Okay, so there will be 3 type of situations we need to discuss. So firstly, let's talk about the with the unconditional. Just say jumps, right? For jumps, we need to wait until wait 2 cycles. So let's say we have a jump here. We have a jump instruction here, and then I will go fetch, decode, execute, write back. Yeah, that's cycle 1, 2, 3, 4. That's good, but as we know, we need to wait until the second cycle. So until we finish the second cycle, we can know whether the instruction fetch is right or not. So let's go for the next instruction. This is the first instruction, and this is the second one. And so, the instruction fetch can always be taken, no matter you need to wait or not. But only after you get a result from the jump instruction, you can know you are right, you are correct or not. So only at this time you need to do the fetch instruction fetch again, because we need to jump to somewhere. That means the instruction 1 should not, the original address of instruction 1 are wrong, so we have to fetch again. Here we will get the instruction 1's address, okay, the new address for instruction 1. So here we will get a instruction fetch here, and then decode, and let's say execute and write back. So how about instruction 2? Instruction 2, I really need to wait for something. Actually no, so we just go instruction fetch here, and write instruction 3 to fetch from here. So how many stores do we have for the jump or the unconditional instructions? So you can see originally for instruction 2, we should happen in the cycle, the instruction fetch should be in cycle 3, but now we are in a stage 4 or cycle 4. So there is one store, right? One store here. And that's same for the instruction 3 and in the future. So we know for the jump, the store, the pipeline stores, so there is one store for the jump instruction, right? And the second situation is, let's talk about the predict, right? The conditional branch, and it will taken, right? Conditional and taken. And let's say we will have the conditional instruction here, okay, and f d x w, right back 1 2 3 4, and we know we until the third stage or cycle we can get a result that is take or not taken, right? And the new address, so we have to wait until the new result. But as we said before, the instruction fetch will always taken, no matter you need to wait or not, no matter your branch result. So it will always happen in the second cycle for the second instruction. Yeah. And then we have to wait. We have to wait, let's say it's a store, okay? Store. And then at the end of the third cycle, we get the correct answer. And since in this situation they will be taken, so the new address we will get a new address here. That means we need to fetch a new instruction from the new address, so we have to fetch again. That means this fetch is wrong. It's a wrong fetch, or fetch a wrong address of the instructions. So we will fetch here in the cycle 4 and then do the decode or something. So for the future steps, we have to do the let's say this I+2 instruction in the start with cycle 5. It will fetch from cycle 5, okay? So how many stores it have to wait? So ideally it should be happen on cycle 3, but now it's cycle 5, so there is 2 stores for the taken instruction condition, okay? And let's go with the third is the not taken the conditional branches. Okay, so still condition, but still fetch, decode, execute, and write back 1 2 3 4, and wait until the third cycle we can get the address. And instruction 1 we always fetch from no matter what happened, right, from cycle 2, and then wait. Okay, let's still use the S. Okay, we will get here. Getting here, we know it's not taken, right? So the new address will not be happen or give to after the cycle 3. That means for the instruction I+1, it's fetching the address correctly. So we can continue doing our next step. Next step is the decode, right? And then the execute and then write back. So for instruction I+2, we can start our fetch from the cycle 4, right? So how many stores? So ideally we should start at cycle 3, but now we have to go to cycle 4. So there is one store for not taken condition. So totally, after we get this result, and it is 1%, it is 9%, it is 6%. So let's get the penalty, right? The penalty will be like 1 plus multiplied by 1%, and 2 multiplied by 9%, and 1 multiplied by 6%. And that's actually 25%. Wow, that's a lot, right? So how can we calculate the speed up? To speed up, we will use the pipeline depth. And do you remember the pipeline depth is actually how many stages, right? So we will have 4 at speed up, and with 1 plus 25%, and here will give us 3.2. Okay, so that's what happened for these questions, and I think that is okay. And if you want to calculate how many faster, but that's the same, right? 4 and 3.2, we will get 1.25. Okay, okay. That's the, and then another thing, if you want, that is how many is the ideally versus the, if we have the branch store. Okay, the faster, how many fast. Okay, so here is the question 9.